Hello everyone, and thank you very much for joining this live event, lesson 13 from the Spring Security Fundamentals stream, and we'll be going discussing about token implementations in OAuth 2 systems. In the previous two lessons I think we started discussing about OAuth 2 and we discussed about the authorization server, and now we are going to discuss about the tokens issued by the authorization server, so that we can then go next and dissect the resource server, and that will be our whole OAuth 2 system. But still a long way to go. Anyway, if you are watching the event live, don't forget that we have a live chat there, so you can ask me questions directly in the live chat. And if you are watching the event recorded, you can still ask questions in the comments section, or you can find me on LinkedIn or Twitter and you can ask me questions there. So what I will do today, I will discuss about tokens and token implementations and way in which the resource server can validate the tokens. But before diving right into our today's subject, I would like to answer a question I received a few days ago. So this week actually, about the difference between the authorization code grant type and the implicit grant type. I know we didn't discuss that, and we actually didn't discuss that on purpose, because as I've told you in one of our past previous two lessons, actually one of them is that the implicit grant type is actually deprecated and you won't use it anymore, and now you have this, let's call it a little bit enhanced grant type called the authorization code, which is basically the implicit grant type with one more step. Is this step here. I will immediately add some labels on the arrows. I've created the diagrams empty on purpose so that I can add the labels, and that will help me with my explanation. But I've got this question about the implicit grant type and the authorization code grant type. What's actually the difference? Where's the security coming from? Because it seems that having this step, it's not really a great deal. I mean, it's basically more or less the same thing, and you only have one more step. But is that really bringing us a lot of security? Does that worth having that step? And yes, it does actually. And even if you won't use the implicit grant type anymore, I thought that maybe it's a big deal to know about them and make a difference about them. So let's start with the discussion about the authorization code grant type versus the implicit grant type, so that I clarify why the authorization code is more secure. And then once we discuss this, we leave all the grant types because we have already discussed them in the previous two lessons, and then we go further to our token implementations. We'll discuss about opaque versus JVT tokens, and of course we won't use all of them now, but we'll discuss the approaches that you can take. And then in the next lessons we will apply all of these approaches. Actually, we will take all of these approaches and we will apply them one by one. We'll make our research server validate the tokens depending on the token type and depending on the things that we discussed today. So that's why this lesson is very important. You need to know which your options are in regards of tokens, in regards of token implementations you get from the authorization server, because depending on the token implementations, then you can decide how you use the token. And when I say how you use the token, I refer to the resource server, because the resource server actually validates those tokens somehow. And when a request gets to the resource server, it has an access token, and the resource server has a way in which it tells if that token is a valid one or not. So that's what we want to figure out, and that depends again on the token type. Now, starting with answering the question regarding the difference between authorization code and the implicit grant type. So you remember in the authorization code grant type, we have these steps. The user tries to obtain a feature, to use a feature in the client app, and then the client app, instead of taking itself the username and the password of the user, it redirects the user to the authorization server. So one big difference here to the password grant type is that if you use the authorization code, first of all, only the user and the authorization server knows the username and the password of the user, and the client has no credentials of the users. It only has its own credentials. It still has its own credentials, but it doesn't store anyhow, or it doesn't take anyhow the user's credentials, which is really important. And then Another important thing is that when, assuming the user logs in correctly and the username and passwords are valid and the authorization server has to issue an access token, it doesn't issue an access token directly. We have seen, we did even test it in our own implementation in the past lesson. It actually first issues what is called an authorization code, and guess what, this is why the grant type is called authorization code, because following the login of the user, the authorization code, this code also called the authorization code, is issued, and it's not directly the access token. And then the client needs to do one more step, sends the authorization code, and then of course the whole purpose of the authorization server and the OAuth 2 flow is to get an access token back, and of course the access token is then used to call the endpoint on the resource server. But if you look a little bit, it might not seem obviously from the beginning why getting an authorization code which we then send back to get an access token implies something more secure. You have the implicit grant type, which was the previously used before the authorization code grant type, where it's basically more or less the same thing. So you still have the user trying to obtain something from the client, and the client redirects the user to authenticate. The user authenticates against the authorization server, and then it directly gets back the access token. So funny is that if you actually look at the implicit grant type on a first basis, it might seem that it's easier and that is actually is better than the authorization code. So why we deprecated the implicit grant type and we invented the authorization code is actually because in the case of the implicit grant type, the authorization code makes a redirect call via that redirect URI you have seen in the previous lesson to the client. But when the authorization code calls the client, well, it calls an URL, and that URL could be faked. So the authorization code, because it's the entity making the call, it has somehow to make sure that it really calls an authentic client. So in the case of the implicit grant type, when it actually calls the client, it actually delivers directly the access code and makes sure nowhere that the the client really is the real client who should get the access token. So I see a question here: is the refresh token sent together with the access token on the first request with the code, client ID and client secret? If your question refers to if the authorization code sends the refresh token, the answer is yes. And you have seen it probably in the previous lesson. If you follow the previous lesson, that's where we have used the refresh token, and you saw when you do the call you get the access token. If you have also the refresh grant type, you also get the refresh token, and we will see it today anyway. So when I get to that, I will show it again. So thank you for the question. Very good question. First call, when you do, actually not only the first call, any call, the first one and all the other calls where authorization is done against the authorization server, you get back not only the access token but also the refresh token, in case the client specifies it uses the refresh token grant type. Only in that case. If it doesn't specify that it uses the refresh token grant type, then of course it doesn't receive an access token at all. Okay, going back to my implicit grant type here. So in this case, it's pretty clear that when the authorization server calls the client, it makes nowhere sure that the client really is who it claims it is. It delivers the access token, and the access token, it's a pretty important piece of information, because it's not it's called a bearer token. We've seen that bearer word, and it actually means that bearer token means that whoever has the token can access the resources. So that's why the access token is pretty important. So you don't want to, you as an authorization server, you don't want to deliver it to someone who is not the intended client for whom the user did the authentication. So if you do that, then we have a problem. And the implicit grant type, in the implicit grant type, it can happen. It can happen that the authorization code delivers the access token to somebody that is not the desired client. So to cover this, instead of sending directly the access token, it sends an authentication code. So what's different between this authorization code? Sorry, what's different between this authorization code and the access token? Well, to get the access token, you need the authorization code. You will say, okay, but isn't it the same thing? I mean, it's the same thing. You can get the authorization code now, and then you can obtain the access token. No, because if you get the authorization code, you still need something very important. Don't forget that any call made from the client to the authorization server is not only a simple call, but it's always followed by the client credentials. So if you as a hacker did obtain somehow, did the same thing as you could do previously with the implicit grant type, but now you got the authorization code, not the access token, now it's a little bit more difficult because having the authorization code is not enough. It's not enough because you need also the client credentials. So now if you really want the access token, you have to prove who you are. You are client secret. So if you don't know the client and the secret, then you can't use the authorization code to get the token. And it's also more difficult to directly intercept this arrow here, because maybe you will say, okay, but what if I do actually directly intercept this arrow here? Isn't that the same thing like intercepting this arrow here? Isn't it the same thing? No, it isn't the same thing, because even if it looks like being the same thing, it's a big difference here on what this arrow represents and this arrow represents. Don't forget, this is not a response, but a request. So actually, maybe it would have been better to mark differently the responses rather than the requested. And if I actually made the here, this is a request like this, and then the responses would be, for example, in a dotted lines, then you might see more easier that this is actually a request and response for redirect, a request again for login, a request because this is a redirect request for authorization code, then a request again to get the access token. This is a response. So you now see the difference between this arrow and this arrow. Well, this is the difference. This is a request, which is easier to fake because you can just interpose into the one who is called, and this is a response, which is actually a little bit more difficult to intercept as a man in the middle. So this is why this authorization code is actually more secure than using the implicit grant type. So this step with the authorization code, which actually seems to be not that important, if you take a look at it the first time, you might say, well, doesn't bring a lot of security. Why did we leave the implicit grant type? It was easier to understand, it was easier to use, it implied less arrows on the sequence diagram. Still is more secure to use the authorization code grant type, because this way you make sure it's more difficult for a hacker making a man in the middle to intercept the access token. So it's much more difficult with the authorization code grant type to actually obtain this piece of information, which is really, really important, which is the access token. And I hope this clarifies the difference between the authorization code in the implicit grant type. Don't forget that we don't use the implicit grant type anymore. So this was an answer to one of the questions I've got this week, and I wanted to clarify, to make it sure that you understand this is not only one more step this is one more step with a really good purpose there. So it really makes sense to have this one more step there. It really empowers the authorization server, makes the authorization server sure it delivers the access token precisely to whom it matters, to the right client for whom the user did the authorization. Okay, that was to answer the question, and now I'm still back to, and let's dive into today's subject, which is actually tokens. So another question I have here: when we use JWT instead of OAuth 2, there is no JWT instead of OAuth 2. There is absolutely no JWT instead of. JWT is a token implementation. We'll discuss it today, and we use it above OAuth 2. So we use it above the same framework we discussed. Maybe you wanted to say, when do we use JWT with OAuth 2, not instead of, because there are not some different things that we use one instead of the other. JWT is a token implementation which we use on the OAuth 2 framework instead of other tokens implementations, maybe instead of opaque tokens implementations, but it's not something instead. They are not two different things I choose from. I choose above OAuth 2 either JWT, either opaque token, but it's still OAuth 2, so it can't be instead of. And when do we use JWT with OAuth 2? So that's maybe what you wanted to say. Well, this is what we are discussing. It's one of the things we are trying to dissect today and to implement in the next lessons. So let's dive into our subject and see why do we use opaque tokens. What are the benefits of opaque tokens when we can't use opaque tokens? Why do we use JWT? When do we use JWT? And how do we use JWT? So we have a lot of questions to answer actually today. So let's see which are the answers to all these questions. But in order to do that, first I would like to again dive into another diagram here and discuss about first of all opaque tokens. So what is an opaque token? An opaque token is a token in which you don't have any kind of information. It's just a string. It's like a password. You don't have information in the token itself. If you get that token and you read it, you see nothing there. You have to obtain information about that token from somewhere else. And that somewhere else, well, you have three options in this case. And those are the three options we want to discuss. Okay, another question. A scenario for the implicit type is for communication between well-known microservices for speed. So the current recommended implementation is to use the authorization token. So the current recommended implementation is to use the authorization token. I'm not sure precisely if I understood correctly if it is a statement or a question. Well, the recommendation is to use authorization token. There is no situation in which is recommended to use the implicit code instead. I guarantee you that. So it's not something you use for speed. Again, what we discussed here, which is the authorization code and implicit grant type. The implicit grant type is a way of doing authorization, very similar with the authorization code, but is deprecated. You don't use it anymore. It implies mainly the same things, but because of the step you don't have when you have a client, for example, and you want to make sure that the client is the real one to get the access token, you need first to use an intermediary step with the authorization code. Usually, when you have a scenario, because you stated a scenario like implicit type is for communication between well-known microservice for speed, I'm not sure what you wanted to say with that, but usually when we do between well-known microservices, it happens that we don't consider a client as one of the microservices. Not all the time it's a true fact, but usually in this case we might use the client credentials grant type. So again, I'm not sure if I understood correctly the question, but when we discuss about the implicit grant type and the authorization code grant type, implicit grant type deprecated, authorization code grant type is what you use. No matter which your scenario is, this should be this should be how you use it. And it's even, you know, that we have a new authorization code developed. If you will read the documentation of the new authorization code, you will see that for the new authorization code, it's a very good possibility that you might not even be able to use the implicit code grant type. Can we use JWT and OAuth2 together? Yes, that's a better question, a much better question. Yes, we can use OAuth2 and JWT together. That's the question, and that's what we discussed now. So your first question was use JWT instead of OAuth2. So that's something that's a question to which you cannot answer because it's not correct. Because JWT and OAuth2 are two absolutely different things. One is a framework for authentication, JWT is a token implementation. You do, however, use JWT with OAuth2, and that's what I'm showing you today. Glad that I have answered your question. Thank you very much as well for the questions. So, yeah, going back now. Again, we are in tokens implementations. I want first to make sure you understand we have two implementations we discussed, the opaque token and the JWT. The difference between the two, the opaque token, you read it, it's just a string, you get no information. That's the first one we will use. And we have three scenarios where we can use it, or the way we can use it is in three different scenarios. And this looks like the following. Let's take it on the diagram. So I have authorization code and authorization server and the resource server and the client. Let's arrange it on the diagram a little bit. And then we know the flow. So the user asks for something, then the client needs to get an authorization code, an access token, I'm still on the authorization code, but access token I wanted to say. So we get an access token back, and then we use the access token to call the resource server. So that's the main flow. And now what we want to discuss is how does the resource server know the token is a valid one. So I get an access token here. The access token is issued by the authorization server. Okay. And then it's used to obtain a resource on the resource server. How does the resource server know this access token is valid? Now, we discuss again about two different token implementations. The opaque token and JWT. First of all, we deal with the opaque token, so we have to take them one by one, because if we don't take them one by one, then you will make confusions. Let's take first the opaque token, it's the easiest. And then we discuss about JWT. The opaque token is just a normal token, you see nothing in the token, you can't make a statement if it's a valid one or not just by looking at the token. So in this case, which are our options? The first option, and let's say the mainly used option in this situation, is to have a call between the resource and the authorization server. So on this diagram we have one more call. This is the call where the resource server tries to find out if this access token really is a valid one or not. And then of course the authorization server responds and it tells the resource server, yes, this is a valid access token and here are the details, or it simply tells the resource server, no, this is not a valid token. So this is the mainly used implementation. Should we do it as well? Let's start our IntelliJ and try to create a new project and test this scenario of the opaque token. So I have to create a new project. It's lesson 13. I still have here lesson 12, which was the previous one. So I have my Spring Security C13, and we always use the latest and greatest Java. And then we have, we need actually the web, we need the Spring Security, and of course we need the Cloud OAuth2 implementation for our authorization server. So I create this this project. I can close the previous one so that I spare some resources, because IntelliJ sometimes consume a lot of resources. And now I have my implementation here. Cool. Very fast to remember how the implementation of the authorization code is done with the current authorization server implementation. So we need to do some configuration classes. You remember we need to actually first of all do the user management, because the authorization server, yes, it manages users, so you need user management. So let's say user management config. And then this is basically what we discussed starting with the first lesson, which is just having a user details service and the password encoder. So let's say you have a user details service UDS, and I will use, of course, a new in-memory user details manager, because I want to make it fast. So generally, you know, you would have stored them in a database probably, but we don't have time for this today. And this should be a bin in the context, and yes, I need a user. So let's make our user with the builder class with username bill, and then we have with password and then a password, and then we need to use at least an authority we need to have, and then we need to build it, isn't it? So we need to build it. Okay, so we need to build it, good. And then once we have the user, then UDS create user U1, we add it to the user details manager by calling the create user method. And then we have the public password encoder. And yes, if you would like, now I can actually use the same as I've done the no-op password encoder. You can do the same. You can use the no-op password encoder like this. You know, this is something you shouldn't use in a real world example. Somebody asked me also, how can I actually do my examples using bcrypt, for example, because you said in lesson 3, I guess it was lesson 3, I can't remember, that bcrypt is the mostly used password encoder actually, and you are always using the no password encoder. Can we actually use the bcrypt? Yes, but usually you will have a database and so on. But if you really want to use a bcrypt password encoder, then yes, you can use a bcrypt password encoder. So new bcrypt password encoder, but then you have to make sure that if you store the user in an in-memory, then the password cannot look like this anymore. It should be bcrypt encrypted, like the same. And then of course that means you should here call the password encoder and call the encode method to make sure that your password is encoded. So either way, you can continue in our examples using the no-op password encoder, and you know it's only for examples. If you really want to make it bcrypt, to see that bcrypt is working, then you can do it like this, but make sure that the user really has a bcrypt encoded password, otherwise it won't work. So that was also a question I got this week. Somebody tried to use bcrypt password encoder, but it wasn't actually encoding the password here, and then it wasn't working. And yeah, of course it wasn't working, because if you want to use bcrypt, you need to have bcrypt hashed passwords as well. So if you really want to use bcrypt password encoder, make sure your users do have bcrypt password encoders, passwords encoded. Otherwise, it of course won't work. So that's it. And of course, then we have to extend web security configurer adapter to expose the authentication manager. Do you remember that we have to expose the authentication manager bin in the context so that we can configure it in the authorization server configuration the way I have shown you, I think, in the past couple of lessons. So you see I do expose here as a bin the authentication manager, and now I'm going to create the second class, which is the authorization server config. So I do split the configuration classes. This is another configuration class, and then here I have to extend the authorization server configurer adapter, and I have to also enable the authorization server, and I will inject the authentication manager that I've just exposed in the context and inject it. By the way, if you have just landed into this lesson and maybe you don't understand all these things, and you maybe think I'm going too fast over them, remember it's lesson 13 here. So if you don't know what these things are, like the authentication manager and why do I have to use it, You can anytime review the lessons recorded on the same channel, starting with lesson 1, because these are components I have already discussed during my entire stream. So of course, if you don't know them, you might find it difficult to understand this lesson, but the lessons are free there on the same channel, so you can review them starting with lesson 1 to understand all the details. Take them in order, otherwise you might find it difficult to understand them. So yes, in this case, I do have to plug in the authentication manager. I will do that by overriding the configure methods, and I will need actually to configure override all 3 configure methods, because for each of them I will have to do something. So yeah, maybe for this one actually I will do it at the end, but all of the others, the other 2, are really important. Let's start with the clients. We can't use a client, we can't do any call if we don't have client credentials. So remember from our diagram here, not only the users have credentials, but also the client has credentials, and the client needs credentials so that the authorization server accepts the calls. The calls done by the client has to be authenticated with the client credentials, and the authorization server needs to make sure that this client is a known client. So here again we will register the client. To make it short, for the moment I will register it in memory as well as the user, but remember that in a real world scenario, again, also the clients most probably will be stored in a database. And then I need to at least specify the client ID. Let's call it client 1. I need to have a secret, which is a password, so let's call it secret 1. If I do something like this, remember that in my context I have used a bcrypt password encoder. So guess what will happen if I do use the secret like this in plain text? Well, it won't work, because if I have in my Spring context a password encoded as a bcrypt, then this secret needs as well to be bcrypted. I have 2 options, however. I will either set this password to be indeed bcrypt encoded, like I've done here with the password of the user, or I can choose to have a different password encoder for my client. For this example, I will choose to set a different password encoder for my client to show you how to do that as well. But remember, if I wouldn't do that, then actually my authorization wouldn't work, because I need to have as well a bcrypt password secret encoded for the client if I use a bcrypt password encoder in the context. So actually, to do that in the configuration here, so this is the endpoints configuration, is the security configuration actually. So the security configuration, here's where I will say, please for this use a no-op password encoder. So if I don't do that, then the bcrypt password encoder will be used. It's that one from the context, and then of course the authentication wouldn't work. So this is all to show you how you can actually have different password encoders for this password and for the other password. It's something that it's real world. You might find this situation in the real world. Not necessarily that you have no encoded passwords, but maybe you use bcrypt for the clients and another kind of encoder for the users. So you use 2 different encoders. So then you need to use to set up your 2 different password encoders somehow. And of course we need to, this was, I'm on a different, method. And you need to set up as well the authentication manager. Endpoints. Authentication manager. So I take the authentication manager via AutoWired, I take it from the context, and I set it up to be used by my authorization server. And besides the client and the secret, then I also need to have at least a scope. You can call it whatever you want now, but in the future we might need to use authorization configuration with the scope. And of course you need to have an authorization grant type. To make it simple, and because it's not related to what we discussed now, we will we will use the password grant type, so not the authorization code, just because it's easier to make the calls. And because you asked me something about the refresh token, let's also make sure that this client has a refresh token grant type to see the refresh token as well, because if I won't add the refresh token grant type, then of course you won't see the refresh token. So the client gets a refresh token only if it's configured to get a refresh token. So do I actually need something else here? No, I guess not. And with that being said, I'm already I'm ready to get an OAuth token from this authorization server. So let's try to start it and see what happens if we authenticate using our user and our client. So I have a client, I have a user, I know it's using the password grant type, I know the client and the secret. Hopefully if I did configure it correctly, and if I didn't do any mistake, then we will see that it's working and we get an OAuth token back, because by default the Spring Security implementation uses OAuth tokens. And that way you will see what an OAuth token is, and then what I want to get to is to see how we can make a call to the authorization server that tells us details about the token. Because with an OAuth token you get the details only by calling the authorization server. So if you don't call the authorization server, the token itself is called OAuth, precisely because you don't see details in it. You will see that JWT is different. So I'm going back. My application started, and I'm trying with a Postman now. So I will call the HTTP localhost 8080 OAuth token endpoint. I'm using the grant type password, and I'm using the username Bill, and I'm using the password 12345, and I need a scope read. All of these are needed because I'm using the password grant type. So I get the scope, I have to provide the username and password of the user, and of course I need to make sure that my client authenticates his client 1 and secret 1. So we do the request, and if everything is fine, we will get back a 200 OK, and you will get an access token and the refresh token as well. I think that was somebody's questions earlier. If we get first time the refresh token, yes, we get the refresh token actually anytime we authenticate, and then we can use the refresh token to get another access token and another refresh token, and we can repeat that until the end. So we can repeat this as long as we need it. So now I get an access token. Let's focus on the access token, because we will discuss more about the refresh token in some future lessons. But the access token, so what if we have more than only one instance of authorization server? Wow, this is really interesting question. So why would we have more than one authorization server? It's only in the framework itself, it's only one. So if you have multiple, okay, you can have multiple, that's fine. But then, oh, I think maybe I know what you mean. Let's suppose you have more this, and then you say, how does the resource server know in this case? Because it doesn't know to whom to ask. Well, you have to tell it. You have to tell it. I'm not sure in which scenario you would have more authorization servers. This is not really realistical, because if you have, let's assume you really have more places with the users, you actually, in this case, we will have a high level layer in which you put as you will actually put it in the front of all the others. So you will have something like this. If you really have the necessity of having multiples, then you will actually, let's say you have multiple authorization servers, you can have, let's say, 3. Then you will basically not go to one or to the other. You will actually, in this case, it will be more easier for you to make one service here, and then this is your authorization server, this high level over all these 3. And then one option to do this is, for example, keycloak, and we will discuss later about keycloak. But anyway, there are a lot of ways you can do this implementation, but let's first start with the easiest, because First you need to understand the easiest scenarios, and then we will go further to more complex scenarios. But if you don't understand first the easiest scenarios, then it's much more difficult to understand this kind of scenarios. So let's go back and see what happens with one first. So you have an opaque token. This is an opaque token. I need to know if this is valid. It's clearly that if I read it, I don't understand anything about being it valid or not. I am not sure who issued this token, for whom, which client, which user, if it's expired or not. Okay, if it's expired, you have it here. And by the way, somebody asked me last time, how do we make it shorter this time? Can we make it shorter? And last time I had the impression it was under the token store, but it actually isn't under the token store. This configuration is actually under the client. So you can do that very easy, if I remember correctly, just calling the access token validity seconds, and then you can use here the number of seconds you want the token to be valid. So that's one of the options. But yeah, that was a parenthesis. Going back to what I was saying, so I have a token. I want to see more details, because if I'm the resource server, I want to see if this is valid or not. I will receive it from a client, and I want to know if it's valid or not. How can I be sure it's valid? So I did another refresh just for you to see the token here, the token and the time. So you see the time was 5000. I've changed the time of the token. Okay, if I'm the resource server and I want to see that this token is a valid one, I go here and I have to call the introspection token endpoint of the authorization server. So the introspection token endpoint is an endpoint called check token. You can see that as well exposed here. So this is the OAuth token exposed by my authorization server. This is the OAuth key. We will talk about it later, probably next lesson. But you also have the check token. This is also called the introspection token. It's an endpoint telling you details about a token. It first tells you if a token exists or not, and then it tells you which is the client, which is the user for which it was issued, if it did expire or not, when it will expire, and so on. So details about the token. And we will call this. Now, it is, however, something to be known. By default, this endpoint isn't accessible. You have to make it accessible. By default, all the requests to this check token endpoint are denied. So in my case, if I will try to call it, I should fail. It shouldn't be possible here to call it. Let's see, HTTP localhost 8080 OAuth check token. It's a get, that's fine. And then I say token equals and the value of the token. But if I try to send the request, then I should be unauthorized, because by default the requests are unauthorized to this endpoint. So what should we do to make it actually authorized? Well, we should specify Spring expression language expression that tells the server how should the user authenticate to be able to access this endpoint. So we do that via the configure method, and here you have the possibility to specify the how is it called? No, is it called? Well, I did forget, but I will find it. So maybe I find after token and the enhancer. Maybe I did choose the wrong. So if it's not here, maybe it's another configure method or something. Let's find it. Maybe this one. I think it's this one. Okay, so check token access. This is the one. Okay, sorry for it. It was the other configure method. So I was looking on this other configure method. That's why I didn't find it. So you can say, for example, is authenticated, or maybe you can say permit all. So let's try it with the easiest theoretically approach. You can, for example, permit all the requests without authentication to this endpoint by simply specifying the permit all expression here. Or you can, for example, say is authenticated. We will try both of them. So let's start with permit all. I will restart my application, and then so username and password will fixed or will fetch from the database. I'm not sure to what username and password you refer to, sorry here. So it's the username and password of the user. Yes, they are usually stored in a database. I'm not sure if if this is your question. So if I didn't answer your question, please be more specific about which username and password do you refer. Okay, so I here have my application started again. I regenerate a token because it's in memory. So if I restarted the application, then my token is not valid anymore. And then I go here and I try to find details about this token. So look, I'm sending the request. I got now a 200 OK. I didn't need to authenticate because I specified that all the requests are permitted, and then I get all the values here. My question in the last lesson, which is the case of having authorities of multiple departments with multiple roles. The relationship between user and department is many to many. The relationship between department and role is many to many. I still not sure if I understand your question, but you should be able to do as you want your relationship between username and roles. It shouldn't be any problem. So David, let's keep that for another lesson because it's clearly this is not related to this lesson. So if I try to answer it in this lesson, I'm skipping the subject of this lesson. So let's try to have this discussion later, and if it's something with which I can help, I will try to help you with it, because it's simply what I understand from you. It's just a simply relationship between roles and users management, which should be something very easy. Not related to OAuth, but related to user management, which we discussed in the first 3-4 lessons of this stream. So let's keep it for a separate video because it's clearly not related to this lesson. Okay, so you see that I was able to get the token details by sending the valid token, and I didn't need authentication. Let's see what happens if you have authentication in this case. So instead of permit all, I will use the is authenticated. So here I'm changing this. And I'm just trying to restart it. And I will try to do the same flow, and you will basically see that I can get a token, but I'm again not authorized. So I copy the value of this here, and then I try it again, and I'm not unauthorized, of course. So in this case, because I specify that I need to be authenticated, I have to authenticate to obtain this value. So let's authenticate, and I'm going to the authorization here. I specify basic authentication, and I have to use some credentials for that. So then you see, if I do basic authentication, then I'm back to a situation in which I can access the details. Usually you will need authentication, so it's not recommended in a real world scenario to leave unprotected endpoints. I've started with the permit all to show you that's possible, but generally remember to don't leave tokens unprotected. So make sure you need some kind of authentication. So in this case, it makes sense to have authentication to call the check token endpoint. And you have seen this way how the resource server can get the information about the access token. So now the resource server knows if the access token is valid, and also got details about the opaque access token. So this is a token where by itself you know no information. The resource server just getting the token has no idea if it's valid or not, but it can, for example, call the authorization server, like by using the introspection endpoint, and find out if it's a valid token and find out details about the token as well. So in this case, this is one of the situations, but I said we have 3 solutions. Which is actually the next one? Well, the next one is having a blackboarding database. So let's say, let me see if I find the database here. Do I find the database here somewhere to use it? Let's try to use this database icon. So you have a database, and this database is used by both the resource server and the authorization server. So this is another implementation scenario. Usually it's better that you avoid having shared databases with services. So generally, I won't say this is something I would recommend you, but it's still a possible scenario. It's still a possible scenario, and the scenario you might sometimes see in real world examples, because even though some things represent anti-patterns, that's not always clear if always some kind of scenario is an anti-pattern. So I always avoid saying that something is always an anti-pattern. I say that most of the cases you shouldn't use that, like sharing databases between services. Most of the cases you shouldn't use that, but generally it's a scenario that's working, and you might find cases in which you will encounter this scenario in a real world case. So how does this work? Well, we can't implement it now because it takes some time, but we will try to implement it in one of the future lessons where I have more time, because for this lesson was only the beginning and I don't have time to do all the examples. That's why we will have to also implement some of them in the future lessons. But with this, I have a resource server, and you have the authorization server, and you have the database. It's pretty easy. I think you can already figure out how this happens. Well, once it's issued, the access token is stored in a database, and then the resource server, once it gets the token, it finds the token in the database, and then it gets the resource. Instead of a database, what are your thoughts of a high-speed cache like Redis? Well, Redis is, from what I know, used as an in-memory database. So if you have 2 different applications, I'm not sure if this is a good choice. But again, implementations are different choice of implementations might be good in different scenarios, so I won't say it's not a good choice. I would avoid now to discuss more about the architectural styles. I prefer to discuss about the development implementation, so make you aware of this and how to implement them, because then you will be able to choose yourself how you want to manage your tokens. You will see that a token can be easily managed by using a token store. The token store being a component in Spring Security where you can specify how you would like your tokens to be managed. So we will get to that probably in one of the future lessons. But yes, you can use Redis if you want. That's possible. If it's good or not, difficult to say. It depends a lot on what you are implementing. So as any other architectural choice, it really depends on your system, on the technologies, and what the applications is doing. So it's not something that you can say yes, it's a good choice, or no, it's not a good choice. Like this one as well. Sometimes even sharing databases might be a good solution. In most of the cases it isn't, but sometimes it might be. It's always better to be flexible with this kind of approaches, because you will find with experience that there are always situations in which you find more opportune to use some kind of scenario. So you see how this is working, pretty easy. Again, the access token is issued and stored in the database, and then the access token received by the resource server is then searched in the database. And you can do that by implementing your own way of storing the tokens, but you will see we even have already an implemented JDBC token store that allows us to precisely do that, and that is what we'll discuss in one of our future lessons. So we will implement this way of working with tokens using the JDBC token store, which is a component provided by Spring Security. You have it already and you can use it whenever you want. So it's pretty easy. And then we have the third option. So that was we had the introspection token endpoint. We had the using a database as blackboarding, so a shared database solution. And now we have also the third one, which is the list solution found in real world scenarios. It's actually a solution that you will basically find only with examples. Is the case in which the resource server and the authorization server is the same application. Because you see, we always refer to them as applications. That's because mainly in real world examples, they are different services most of the times. But in case of OAuth 2, which is only a framework, they represent only two different roles. And those two different roles can really be taken by the same application, which in this case, even if you have an opaque token, because it's generated, it's issued by the same application, that means it can be read and understood by the same application. And I have 5 more minutes and I can even show you how to do that. I can even show you that this is possible. But remember, this is a very theoretical example. This is a very, it's an example that you would actually only use for demonstration or for a lesson. But it's very difficult to believe that in real world examples you will find often situations in which the same application represents both the authorization server responsibility as well as the resource server responsibility. But to do that, let's show you how you can make your authorization server a resource server as well, because in the next lesson we'll actually do precisely that. We will try to implement a resource server, and we will start actually implementing resource servers with all the discussed scenarios. First of all for opaque tokens, and then of course for JWT tokens. So to end my lesson here, let's end it with just making this application be a resource server as well, and use opaque tokens to call an endpoint. So of course I will need a new configuration for that. I will say resource server config. That's my configuration. It's a configuration class as any other configuration class. I use the configuration annotation, and I have to enable the resource server for that. And that's basically, I think, everything I have to do. And then I need an endpoint as well, because the resource server is the one hosting resources, which are endpoints that are called by the clients. So let's create a controller, and then inside the controller I do create a hello controller, and then I do the rest controller, and that's a very simple endpoint, just to prove that's working. Yeah, so we have a get mapping and the path. Good. So I will now restart this, and I will try to call the hello endpoint from my postman, see what's happening. So do you see that in this case basically the same application really is authorization server and resource server at the same time? Of course in this case I might use opaque tokens just because, being the same application, it knows about the tokens, so I don't have to do anything about it. It simply knows about them. I don't have to call any endpoint. I don't have to store them in a database. Of course, in the next lesson, you will see how we implement the resource server, where it really calls the check token, and another one where you will see it using a database. So when we use OAuth 2 and JWT, can you please tell us some scenario? That's a good question. It's almost any time, almost. So in 99.99% of the cases you use JWT. So of course I've started with opaque tokens because it's important you know the opaque tokens, But yes, you use JWT in almost all the cases in general when communicating between the resource server and authorization server. However, I'm sorry to let you know that you will have to wait until the next lesson at least to find out how we use JWT, because now we don't have the time to do that. But you first need to know tokens. So remember, you need to understand all the kinds of tokens. You don't do the mistake just trying to understand JWT because they are used and I need to know them. No, you don't need to know JWT, you need to know Spring Security, and you need to know how opaque tokens work, how all the components work, what all your possibilities are. You will understand JWT also in the end, but you need to understand all of them. So make sure that you understand also opaque tokens, because there are situations in which you will see them used and not JWT, even though there are not as many as JWT. And then you will see, because I've put it here as a second, I didn't put it here for nothing, I will discuss it. It's not today because I don't have the time, but in the next lessons I will discuss JWT. So if you will attend the next lessons, you will find out when do we use it and also how do we use it. But please have some patience, because it's not possible to simply discuss all of them at once. So sorry, I cannot answer your question now precisely, because it takes me maybe not one lesson but a couple of lessons to discuss about the JWT. And if I'm thinking clearly now, it might take me more than a couple of lessons, because JWT is not a simple subject. So we will have a lot of things to discuss about it. Okay, so now the last thing of today, and yes, again, I promise you, as I've promised from the beginning of this stream, is lesson 13. I won't end this stream until I finish discussing everything important about Spring Security. So even if we will have 20 lessons, because that's what's needed to discuss all of them, I will discuss all of them here. So just make sure that you watch the lessons. I will name it accordingly. My recommendation is try to learn all you get from this stream, because everything is important. Don't skip lessons and go to some subject, because you won't understand it completely, and security is quite an important subject. Sometimes not understanding it completely might make you enter vulnerabilities into your applications, and that's really something you want to avoid. So I was actually making now my application be a resource server as well. So now I'm going here and I'm trying to call the hello endpoint, and of course I will fail because I'm not authorized. It tells me, yeah, you need to be authorized because I'm a resource server. So if I'm a resource server, how do I allow you get access to the resource? Well, of course you need a token, because that's OAuth 2. The client needs a token, gets the token, calls the resource. You don't have a token, you don't call the resource. Pretty easy. So where do we take the token from? The same application, of course, because it, in our case, represents both the authorization server and the resource server. So I'm going here, I'm getting a token, copy the token, I'm going back to my tab with the hello, authorization, no, sorry, headers directly, because the only thing I need to know is put the authorization and the bearer token. Remember what this bearer is? It tells you that anybody having the token can call the endpoint, and then you send the request, and then of course now you get back a hello because this is a valid token. In this case, the resource server didn't need to call the authorization server because it's itself also authorization server. But this is not, again, a really real-world practical scenario. So that's why the first two scenarios we discussed, they are really important in terms of opaque tokens. One of them is the check token endpoint, the introspection endpoint. The other one is having a database and using blackboarding. And now, I will actually end this lesson with the second point here, because I don't want to leave it untouched. Indeed, I won't implement it now, but I want to first tell you the difference between JWT and opaque token. And then we will discuss all these scenarios in the next lessons. JWT is different than an opaque token. Not only it's a string, but it contains information. And it contains information about everything you need to know about the authorization event itself, So the user, the client, if it expires or not. And it also contains information about if it's valid or not. So maybe you're thinking, how can a token contain information about if it's valid or not? How can a token prove himself valid? Very easy, using cryptographical signatures. So the JWT token, which actually stays from JSON Web Token, is a token usually signed and sometimes encrypted as well. You sign this token, like the authorization server signs this token using a key, and then the resource server needs a key to prove that the token was correct, is valid, is signed indeed by the authorization server. In this case, when you use a JWT, you don't need to call the authorization server anymore or to have a database, because all the informations are in the token itself. So that's when you use a JWT. You use a JWT if instead of getting the details by calling the authorization server or by having a database where you store them, you need to parse the details from the token itself and send it from the entities of our system throughout the requests. So that's the big difference between an opaque token and the JWT. Opaque token, it's called opaque because it doesn't say anything about itself. JWT token is an implementation where details about everything are inside the token itself. And then you don't need anymore to have communication between the resource and authorization server. So in the next lesson, we will discuss about how to use opaque tokens with check token endpoint. We will actually implement it because today we only tested it from Postman. So I would like to actually implement the application itself and make sure we can use it. And then we discuss about how to implement the blackboarding with JDBC token store, and we discuss about the token stores. And then we discuss about the JWT and everything related to JWT keys, symmetric signing, asymmetric signing, using the key endpoint. We have a lot of things to discuss about it. Okay, so cool. That was for today. Thank you very much. Thank you for all your questions. And for the question related to the user management, David, I think the best thing would be, I'm not sure if you have followed the first lessons, but my advice would be, if you didn't, to just follow the first lessons. And if they don't answer your question, then leave me a question on LinkedIn or Twitter and just describe me the scenario precisely in that question, and I will try to understand it and create a separate video about that to answer about this user management and scenario. One more question. Yes, let's see which is the next more question. Hope I can answer it now. So I have one more question. Yeah, I have one. I'm here, and indeed it's a little bit of a delay between when I'm saying things and when you receive them. But I've seen your message and I'm still waiting for a question. So let's see which is your question. Okay, still waiting for the question. Okay, because until I get a question, yeah, I wanted to let you know that in the next lessons again, we will continue with our practical examples of opaque tokens and then JWT. And again, please be patient and allow me the time to do that. I can't in an hour discuss about, I know you would like that, you would like me to do that, I would like me to tell you that it's that easy and in 1 hour I can teach you everything about OAuth 2. It won't happen, I'm sorry. I really need a lot of lessons. I need at least a few more lessons to discuss all the needy details because it's a complicated subject. But believe me, it's really worth it. This is really important information you need to know. So can we use only JWT for API security? When you say only JWT, I assume you want to you mean without OAuth 2. So just use your own custom implementation of some security filter with JWT. That's the question. So if that's the question, if I understood correct the question, the answer is yes. And in very simple systems, you could do that. It's actually something you can do. If your system is very simple, maybe you don't need to actually rely on the whole OAuth 2 system. However, make sure that the implementation, when you do custom implementations, it's also much easier to introduce vulnerabilities. It's much easier to do mistakes. So when you do it, when you do implement it over framework like OAuth 2, you somehow rely on code that was tested before and that others use it. When you do implement your own filter that's generating a token and then use the token, that will work. And if it's a simple application, then it might be more comfortable for you, because yes, of course, it's a much simple implementation. You only take what you need, but at some point you have to be careful to really cover all the cases so that you don't expose vulnerabilities into your application. But I don't I'm a very flexible again person in terms of architectures. I always say any solution could be a good solution. You just have to treat it right. I've seen that implemented, and I've seen that implemented in a few systems, so that making your filter with JWT, and it was properly implemented. And I say, why not? Yeah. Even in my book, in one of the chapters before diving into OAuth 2, I present a scenario where you actually use JWT at the filter level, and I would say, yes, if that's the way to go, and that's the better way, that's the simplest way for your application, then why not? It can be a good choice depending on the system you are implementing. Perfect. Thank you very much for all questions, and I have to end it here. But again, this stream is still continuing. I will do plenty of other lessons on this, and I still have to discuss a lot of things about not only OAuth 2 but Spring Security, because again, when we finish OAuth 2, and we still have a lot to discuss on OAuth 2, but when we finish it, we discuss authorization and MVC matchers and regex matchers, and then we discuss reactive applications and Spring Security, because Spring Security applies differently on reactive applications, and then we discuss testing and integration testing with Spring Security. And see, we still have at least as many lessons I think we have already done yet. So stay tuned, because there is a lot to learn from this stream, and make sure you learn all of it, because this is very valuable information. You will use it for sure in a lot of real world scenarios. Until next time, thank you very much for joining, and thank you very much for all your questions, and have a great time for study.